SMS.
Sweet.
Hi, Max.
Hey.
Hey, Max, what's up?
All right, Jacob, the floor is all yours.
Thanks, Max. All right, everyone. So today I am taking the ambitious goal of trying to build a web scraper and also a solver for Wordle. I'm confident we'll get through the web scraping part and lay out how the solving part will work. We will see how it goes. And there's going to be a focus on learning how you can do this for some of your own projects, because I think it's small enough that there are some key concepts involved and it should be fun. So what I'd like to talk about first, I think, is the most useful bullet you can get in this talk. It took me about 2 years to learn. You guys are going to learn it in a few seconds. So let me make sure I can share my screen. And, oh, I have to do, okay, sorry, I have to change some security settings. But
I may end up having to quit and restart Zoom. Just
oh, damn.
Yeah.
Okay, let's see if I can do it without, but you're probably right. Yeah, I do have to quit. So I will be right back.
Sounds good.
All right, can you hear me again?
Yep, and I made you co-host again.
Thank you. All right, so here we are. And the thing that took me so long to learn was how to figure out if you can use HTTP requests to scrape a site and when you have to do something fancy and run a browser to get it. And the answer is basically if it uses a bunch of JavaScript or if it has things laid out in a nice request format. So I'm going to show you two sites side by side that kind of exemplify this difference. So first, let's take a look at Wordle. You guys can see my screen, right?
Yep, nice and clear.
Okay, so we'll find the Wordle site. And if we go into here and start running it, I'm going to go into the inspect and look at this network pane right here. So we can see a bunch of different things have loaded. I'm not really caring about what these all mean exactly. But what I do care about is as I interact with the site, how do these change? And if there's a bunch of changes, that means there are HTTP requests and responses. So if we pick a random word in here and we start typing things out, we can see that there's not anything changing on this network tab over here. There aren't any new get input requests. And this makes sense because Wordle is a site that actually uses JavaScript. In contrast, if we go look at this site called Microcorruption, which is another thing I've been scraping, we can go to the network tab and notice how whenever I click anything, or, okay, so whenever I click on anything, we're starting to get a few things show up over here. And I might need to log in again. But moral of the story, we can see stuff start to happen. And this is a really good indication that you're going to be able to write your own requests that do things like this. For example, we can see this is a post saying that the session is alive. And here's a GET request loading HTML content about the page we just clicked on. Right, so these are two very different things, the Wordle and the microcorruption. Moral of the story is microcorruption, use your beautiful soup, use your requests, anything that interacts with HTTP requests, and it's pretty easy to do. You can figure out what the site's doing with that. But Wordle is all in JavaScript, which means you either need to run JavaScript locally and see what's happening and run Wordle locally to do it, or you want to use a browser to automate it. So that's what we're actually going to do today. So I'm going to close out of this real quick and grab this web page. And let's jump over to our project. So one really great tool for doing browser automation that has changed over the years is called Playwright. And this used to be something called Puppeteer for Google, but they wanted to use web browsers that were other things than Google Chrome. So basically the dev team just jumped over to Microsoft and said, now we're doing the Playwright project. And they just added different browser support. So we're going to import this right here. And just to show you guys how this works, I'm going to get a quick little demo up. Just basic Python stuff. And you use it kind of like you would open a file handle. Right, so this is the sync library, which is just easier to deal with. If you need to do things faster, you'll use an asynchronous version. But you can just create a browser like this. I'm choosing Chrome. And one nice thing is you can run it in the background, but here we want to see what's happening. So we're going to do it this way. And I'm just going to import time and just add a really long. So if you've done all your imports correctly, should be able to just run this guy. And it will open up a browser for us eventually. Let's see where it is. Oh, and it didn't open a page because I didn't tell it to. But this is a browser we can automate. It's not a regular Google Chrome. And we're going to do Wordle with this because we need to do JavaScript interrupts, so we can't do requests. So I'm just going to write out the quick boilerplate to load the original page. And let's see how that works. And here we are. So we're at the Wordle website right here. And this is what we're going to automate, basically by telling the browser to simulate things we do by hand. So I'm basically always just going to have inspect up, and that's going to be our workflow. And we're going to try to get the page to do what the human would like. So first we need to get this thing out of our way. So you can do that by just clicking literally anywhere. So I'm just going to pick an element on the page to click out of here and basically get rid of that pop-up because we're going to have to do that every time. So since we'll use it later, let's just try to pick whatever HTML element the game has. So maybe board container or board is a good choice. So let's add this in. And this is kind of going to be the layout of the whole scraping part. You just sort of keep adding on layers of things you'd like to do. So it's going to take a session of Playwright. And I think it's something like, maybe we'll just call this page in here. And we need to be able to select whatever element we were just looking at. So these are CSS selectors, which are just sort of annoying to learn unless you know a bunch of web dev. But we'll just fill that in as we go, and you can always look them up. So let's see if this clicks on the right thing, or if I messed up what my board is, or like got the hash wrong. It's supposed to be a different identifier. So after it loads, it looks like it tried to click something and failed. Let's see what happened in the console. Unrecognized feature. So I think I was supposed to use something other than a hash. I'm just going to look up real quick what I'm supposed to be doing.
And can you easily like test which, for instance, test that click function by just typing it into this console and seeing if it works? Or does that not really work because you're missing like the context of where you've defined what the browser is and the page and everything else?
That is a good question. There are a lot of things you can test. I think the browser interoperability, the API might be different. Okay. I'm sure there is a way to simulate a click in JavaScript, but I don't think it's the same way as writing this one right here, but we can check it. So let's just do that. And since I had the wrong command here anyway, let's just go like this. And okay, see what this thing is called. Instructions. Okay, so yeah, let's pick something. Okay, so actually the thing I was looking at before is game health. So I'm actually just going to go here, and I should look up my documentation because it was slightly wrong. So let me just fix this real quick. That's what it's supposed to be like. And let's see if we can click something here anyway. So what is this out here? Let's try to find something by div ID. So or what was the ID just now? Let's see. It looks like it's called game, the ID. So let's see if we can see if this gives us a result. And if this doesn't work, I'm probably just going to move on. Because I'm forgetting the command there. Oh, it's maybe I can just do query selector. Okay, that's saying I'm typing the wrong thing. So it might just be the wrong thing for ID, but usually there'll be something here and we could potentially click, but it doesn't look like that's a command. So we're just going to do it with the Playwright API for now. But you are right that there are ways to do a lot of the checks and tests you would like within the browser. And we'll get to that later, actually. So it looks like tweaking this a bit and fixing the syntax, typing this game help element does avoid the menu. So now we're one step closer. And what we'd really like to do is a few things. So to do the solver, we're really building on this kind of interoperability that Cory Doctorow was talking about. So a lot of people have written Wordle solvers, but we want to do it in a way where we're not just solving a version of Wordle when we input everything. We want our solver to literally use the website. That's where this is a bit different and give us another input. So we're going to basically play the game on command line and then write a solver for our command line thing. So to do that, we need to be able to put input into here and also get the hints data back. So let's just sketch that out in our code right here. So maybe say like guess word or something. We want to guess an entire word as our input. And then want to get the hints page and then maybe which number hint, because there are 6 different options. So guess number. That makes sense so far? Is this framing?
Yeah, it makes a lot of sense.
Sweet. Okay. So if we want to be able to provide input to here, we need to see, well, we know one thing is that typing stuff on the keyboard fills it in up there. So if we can do keyboard events, we don't have to worry about selecting this exact thing. What we need to do is type something in, hit the enter key, and make sure it's something that's in the word list. So first, let's actually just go grab that word list right now. So since I was saying that Wordle is a JavaScript file, we can go look in here, and it's minified to make things faster, which is really terrible for us. But I happen to know the first word in the word list, which is here. So let's just start here and let's literally copy all of it so we can have a list of all valid words. And this just lets us avoid the case of when we have to press enter and it doesn't go through because it's not a valid word. All right, let's go this way. Maybe I should put this in a different file, but for now we're just going to try. Okay. Almost there.
There's a bunch of Yiddish in there near the end.
Yeah, seriously. All right. So that's really painful. Maybe I should put this in a different file. All right, I'm going to quickly do that. And I'm trying to think what the best format would be. Maybe I can just leave them all comma separated and parse it. I think that's probably going to be easiest. All right, so let's just dump this in here. I'm going to cheat a little bit and fix one problem that I've run into before, which is that this is actually 2 word lists. There's one of words that will actually show up and one that words are accepted. So for example, this is never going to be a daily word. So I know there's a few more braces in here and another word list I have to find, right? So here's the second list. we're just going to cut this out and just pretend it is one big list like that. All right. So now let's write something to get our words maybe in the main. And just as a sanity check, let's just make sure all of these are length 5.
They're going to end up with the quote characters, right? We'll have to clean them off somehow.
That's a good point. We will have to clean the quotes. Yeah, so maybe what we'll do is for each of them, we will strip those. Thank you for that. Okay, so. All right, well, not as pretty of a one-liner as I hoped, but let's see if it works.
Another way to one-line it would be to JSON parse it. You just put brackets at the start and the end.
Yeah, that's a good point. Maybe I should have done that. But let's just see if this works since we're already there. False. Damn it. Okay. All right, so maybe instead of printing if they are all that, we'll print anything that isn't.
I would do like the first 20 or something, like colon, you know.
Yeah, I for own words, if when I not equal. And then, yeah, we can do the first 20 of these.
Yeah, exactly.
Zymic has a new line afterwards.
Yeah.
Okay. Gross.
I do like the idea though of Wordle where actually anything that's like valid ASCII could be part of the word.
ASCII characters.
Yeah, you could have Wordle, but it's all based off that talk we had about the hidden character attacks. Trojan.
Yeah, exactly.
That'd be really funny.
All right, let's see if this works. Okay.
Be like, psych, motherfucker, the words are going backward.
All right. So it looks like we've got our list of words now. So know that if we enter one of these, we should be good. And this is going to be our main game loop here. So let's just build that out and say we get 6 guesses. So while something about hints. So I guess and this is going to have to be a parameter, like I guess the guess number or hints or something. I guess we'll just have guesses saved somewhere. And this is going to return a Boolean. So while not all correct, and number of guesses is less than 6, then we're going to have our main game loop where we guess a word, get the hints, and sort of repeat. So I guess here we need a few things. We need a list of our guesses, which will empty out. We need our hints, which will be empty as well for now. All right. So now we want to be able to guess a word, even if this is an infinite loop right now. So let's get back to doing our web scraping section. And we need to implement this. So as we were saying before, we need to basically type something in and then hit the enter key. So to do that in Playwright, we can do it like this. And I'm just looking up some of these Playwright instructions because I never remember them and it's not super interesting to how the scraping works, but we've got to do it. So I guess I lied and we're not actually going to use the keyboard. We're going to find the keyboard element. I'm just writing down what I have and I'm going to show you guys how we got here in a second. So this is actually a click letter or press letter or something. All right, so let's see how we got to this. Sorry about that. You guys have any questions so far?
Nope.
Okay.
Yeah,
Nice.
so far so good. I'm keep installing Playwright over here to follow
Oh,
along.
sweet. Okay, nice. Gonna, oh yeah, we have it in this page. Okay. Yeah, it has a slightly weird install instruction. Oh man. What I get for changing too many things before running it again. All right. So if we look at a particular key on this keyboard, this is one of those things you sort of do manually, different websites, and see what the easiest way to get at something is. Here, it looks like a keyboard is really nice and laid out, and there are all these buttons that have this data key property, and if we just happen to put the right one in and click that, it will do the thing that we want. We don't need to worry about the backspace because we're just going to type in valid words from the start. And let's see how this enter key works, because besides backspace, that's the only non-ASCII one we see, but we will need to press it. So it looks like they're literally using Unicode. So I'm just going to steal this, and we can enter that as a key in our Python script as well. So when we guess our word, we just need to press letter for all the correct things and then press the enter key. At the end of it, we need to press this thing. Press letter, page. And we also need to press letter 5 more times before this for all the things in the word. So I could do a check to make sure word is linked 5, but since we're going to be using things from the word list, I'm just going to ignore it. So for letter in word, press letter page. Okay. Do you guys have a favorite 5-letter word we should test this on? And if not, I'll just pick a random one from my list or something. Okay.
We do cheat, C-H-E-A-T.
Sounds good, because that's exactly what we're doing today. Page. Okay. See what happens. And key is not defined. Where did I put it? Okay. I guess key is a better word than letter. Awesome. Okay, cool. So now we have a way to do input. We just need a way to get the hints back as output. And we'll basically be finished with the scraping section, and we can just go work on the solver. So yeah, that's sort of why I thought this was a good project, because it's surprisingly tractable. We haven't written that much code here so far. So getting the hints, how will we do this? So let's look at these in here and see how Wordle stores this. Stores the individual ones as tiles. That makes sense. Should be more of them down here. So they keep going across, and then there's a row for each. So if we can get access to this thing called board, then we can get at all of the game rows in it. So Max, this actually goes back to the question you had earlier as something we can find inside JavaScript in the console and test it a bit faster, and then we'll modify it for Playwright. So syntax is a little bit different because this is now JavaScript instead of Python. But we want to find the thing called board. And I forget what the syntax is for ID. Let me look this up actually. CSS ID selector does seem like it's a hash. Okay. And now to close this. Okay. It's saying there we can't find board, so I must have my syntax slightly wrong or doing something a little bit wrong. And let's see what else we can get instead. Board has here. We can also look for a game row, which we don't need to do an ID for. So there is a way to do ID, but this is also just a type of HTML element. So I think I can just type game row instead and get rid of the hash, and that'll probably find one. Now, what am I doing here? I feel like this is right. This looks like code that I have working my previous one, and I don't know where this error is coming from. I had to capitalize document for the JavaScript, I think. Let's see if this works. Okay, no, I'm pretty confused actually. I'm just going to try this in Playwright to make sure I'm not going crazy, because I know it a bit better.
It's any consolation, as far as I can tell, you're doing everything right, and I'm also unable to get document that get element by ID to work.
Thank you. Yeah, I'm not really sure what's going on. I guess I should run get hints probably. I know that Playwright is doing this thing, or no, they're not. I don't think they're deprecating. I don't know. Get hints takes guess number, so I guess we'll say 1 since it doesn't really matter yet. And hopefully that will print out something. Okay, so it looks like we have 1, 2, 3, 4, 5. How many? 1, 2, 3, 4, 5, 6 things, which correspond with 6 rows. So normally I would check it in console max, but right now I'm just going to move on because I'm not sure what the issue is there. But right now, we in Python have access to the row that holds our guess. And now let's try to see how we can interpret this, because inside of the row, we have a whole bunch of game tiles with letters that we guessed before, so we don't necessarily need to check them. And there's this thing called evaluation. So absent seems to mean that the letter is missing from the word overall. And correct means it's the right one, it's green, and then the yellow one, which you can barely see over there, is present. So if we get these evaluations back, we will have hints for that word. So to get all the hints, maybe instead of guess number, we can just try to get all of them at once and get rid of the empty ones that we haven't guessed yet. So these are all of our rows. And we want the tiles for each. Maybe I'll leave the guess number in. The tiles for each row. So the tiles will be, and I'm going to modify the guess number a bit because we index our guesses at 1, not 0, like the computer. And then this is because the game tiles are inside the row. And let's print these out and see what we get here. We get 5 tiles. Five. Okay, so we have 5, but we need to get the attributes in them. So this is one thing that Playwright does well, is this lovely thing called get attribute. So even though it's overkill, since we put the proper letters in, I'm just going to write functions to get the letter and get the tile, or the evaluation, I mean. Did I spell that right? No, I didn't. And a hint for a specific row.
I think you still didn't spell that right.
No, you're right. Thank you.
No worries.
Valuation. Okay, so then we need to apply that to each tile. So maybe we'll just return a tuple. Attribute, not letter. And then let's print out the result of get hints and see what happens. And if we get something good, we'll add it to our guesses. Sweet. So this is great. Now we have, oh, and actually just for fun, let's sort of close the loop and each time use our word as input. So let's just get something that lets us play from the command line, which is surprisingly not far off. So hopefully Corey would be proud. We've just closed the loop on his ComCom stuff, I think. And then let's see. Add the list of the new hints to the overall list we're keeping. And I guess we have to add this to our guesses. So and here we'll do our guesses -1. And here we want the length of our guesses. So if the length of our guesses is 1, then we want to get the hint for the first row, and this will keep incrementing properly, is the hope. So let's see if we can play through the command line now with words interface, obviously. So guess a word, try cheat. And then just some other random thing to see that it keeps working. And there is a problem, it seems. Let's see if there's any error inside the console. Sorry, it's a little bit bumpier than I thought, but we're almost done with the scraper.
I'm impressed with how non-bumpy this is.
Thanks, Max.
Nothing like when I code.
Why is it not doing anything?
When I code, my Google searches are like, how do 1 + 1 = 2 in Coq? ?
Yeah, it's only printing guess a word once, right? Where you kind of expect it to print it every time.
Oh, that's a good point. You have found the bug. Congratulations. And thank you, I appreciate it. That was going to take me way longer to get, I think. Sweet. But there will be one issue here we can see, which is, what if I guess things really fast? Okay, that actually was all of them, but I think there might be bugs with input if we don't wait for the program to finish and then we try to get the hints. So I'm actually just going to time how long it takes for the letters to flip up after we add a guess and just add that as a delay, just in case. Ready, set, go. All right, that was like 2 seconds. So let's just add that right after each guess before we get the hints. So time, sleep. All right. Sweet. So I think besides checking if we won the game, the scraper seems to be done. And now we're just going to work on logic for solving this. So I guess this is a good stopping point for now. Do you guys have any, do you want to do discussion? Do you want to keep moving on to logic? Do you want to talk about ways we might approach this next problem, or filling out the details of scraping to make sure like all the letters are correct and stuff? What do you guys want to do?
I mean, just one interesting thing that occurs to me is like, we're immediately being limited by the speed at which some animation plays, right? And so if we really wanted to do this at scale, let's say that we were elite hackers and we wanted to solve 100,000 instances of Wordle simultaneously around the globe, we might want to just delete the animation code, right? Or whatever that is.
Yeah. Yeah, you could probably do that by modifying the JavaScript. I think that wouldn't be too hard if you unminify it and read the program. I don't think it's super long, but I do not know how to do it and will not be sharing today. No, but that is an interesting thing. What about you, Matt? Things good so far? Any questions or comments at the moment?
No, I as Max said earlier, I'm impressed with how smoothly this has gone.
Thank you. Me too. I was really worried at first. But let's see. So I guess I have ideas about how I'm going to do the solver, which makes sense because I have written a program like this before and prepared for the talk. But I'm curious, given our hints, that maybe I'll just print out for you guys one more time, but we have a full word list and we get to know the details from these colors as hints. And I'm curious how you guys would potentially approach this. If you want to talk about it, if not, I'm happy to just go through.
Right. I mean, I guess I would try filtering the word list by things that match the hints we have so far.
So for example, if we put in sword, and I should print hints after we get them. So let's just do this one more time. All right. So given this is our first guess, and these are our hints, actually, maybe I'll do something a little bit easier, like cheat. So I guess, oh man, that's long. Okay. Anyway, this is our first word. We'll just pretend this guess didn't happen. And looking at this guess here, how would you like to prune the word list? And I'm putting you on the spot because this is exactly the plan I had to work on this today as well. Or you can just pick anything. Like, what do we know about these guesses? Like words we might never check after this.
Right. I mean, I guess the strongest, like for each type of hint, I guess we have a slightly different filter, but for correct, for example, right? Like if any words that don't have A in the fourth position.
Right, those would stay. But anything that doesn't have an A there, we'd prune out. Okay, I like it. That is what I was going to do. And I think maybe for the next 10 minutes or so, we should work on adding in some things to filter and prune this down. And then we can find out why Wordle actually makes this surprisingly complex, and it won't quite work unless we might write a really complicated hint for how present does things. And I'll let you guys think about why we can't just do the simple thing for present that we're about to try to do. But all right, I guess since we're trying to write a solver, we'll get rid of the human interaction here. And instead of saying we're going to do input, we're just going to pick something from the rest of our valid words. So maybe we'll have a list of words and we'll say they're plausible or something. And first, plausible starts with everything. And then after we get new hints, we want to prune this down. So we can prune, say plausible is equal to the pruned version of itself. So we'll give it in words and guesses and try to prune it from there.
And hints, probably, right?
Oh, hints. Yes, thank you very much. All right, so here's a loop. We're going to append something to guesses. We have to figure out what to put in there. And I'd say the answer is, who cares, as long as it's in our plausible list. So I'll start with the 0th thing here. And if we're running this correctly, we have all the possible words, so we shouldn't get any index out of bounds errors, because there always is a solution, and we know our solution is in the list. So we don't have to do any checking on this. We're going to guess with the most recent guess we've added, which we just picked from plausible. Then we sleep a bit, we add stuff to our hints, and we prune plausible. So I claim that if our prune works well, that we've actually finished the whole thing. Prune and something to make sure all of the letters are correct are all we need to make this work. So I'm just going to write all correct real quick because it's easy. So if we take the most recent guess, and if linked 0, we have to return false. So. And how are you guys doing on time? Do you want to do discussion right now? Can we code for 10 more minutes? Do you want to stay after? What's the vibe?
I have to leave on the hour, but you guys are totally welcome to keep rocking and rolling with this after I go. I don't know exactly. I think when I leave, if I leave it recording, it would probably end the recording when I leave, but I don't really know.
Okay, that's fine. So we'll maybe stop after we get a few rules down and then see where we are from there.
Sounds good.
So I was wrong.
We can always do a follow-up later.
Sure. Okay, sounds good. Yeah, actually, that might be a good idea as well. But yeah, we want all correct to take hints instead of guesses. And our hints are a tuple, right? So we basically want all of this evaluation to be whatever the word or the thing for them being correct is. I forget what that is. I think it's literally the word correct. So if everything in the final guess or hint, everything in the final hint says correct in the second element of the tuple, then we're good. So I1 equals correct I in hints. All right. So I'm actually not going to be able to test this yet because I don't know what the solution is to the Wordle today, but I'm just going to trust on faith that this thing is good. And now let's add what Matt was saying we could do for prune. Let's write out a prune function here. What does it take? It takes words and hints. All right. So let's write out a little function that handles the case of the green letters. Would you mind describing one more time what that what the rule is for green letters, Matt? You don't have to write the code, but just
right. So yeah, I guess I would say we would keep all of the words that have you know, the correct letter and the correct index.
Okay. Okay, that makes sense.
I would say the converse. You're going to discard the words that do not have the correct letter and the correct index.
Okay. We're going to keep the word. Okay, yeah. I think they both mean the same thing, and that converse might be, or I guess they're the same, right?
Mm-hmm. Yeah, I guess I'm thinking in terms of like a filter function, right? Like your filter takes something that returns true for.
Okay, so that's a good argument in the direction of keep correct, although both would work. So if we say we want to keep correct for all of the words, we need to say what that means, because our guess might have a whole bunch of different letters that are correct. So I'm going to say that keep correct takes a word and also a list of spots that have to be exact matches. So let's actually do something that'll be really hacky and maybe might be a bad choice for other rules. Let's just check. So if we say, what if we say for known letters, we just fill them in their locations, and for unknown letters, we do dots, right? So in this case, this one would be green. All of these would be yellow or black. So, or maybe this is more complicated than just actually, because that would be changing the data structure. Perhaps we can just take the hint and enumerate through and only look at the ones that are correct. So I just lied. Let's do it a different way.
Yeah. Do our hints retain? What was hints again? Was it a lists of tuples?
Like, yeah, it's a list of tuples. So hints looks like this.
So is it only the most recent hints from the last guess, or is it the combination of all of them?
Good question. You're right. Hints looks more like this then. Another one of these. That's a first guess. Oh, hopefully I don't kill my Python formatting. It's probably fine. So it looks like this per guess. So like that. Does that make sense?
Right. So I guess, yeah, we would want to transform that somehow into, yeah, something that tells you which index has to have which letters in it.
Right. So maybe for correct, we can flatten the hints. Right?
Well, we have to retain the index somehow, right?
Yes. No, that's a good point. So maybe we can just, since we'll have to do this for other words too, we can say for what's a good word for the guess hints in, maybe like this, right?
Mm-hmm.
We'll do a filter every time and maybe keep a working list of valid words. Get a Python deep copies if I call the list, but let's just do that. And then at the end, we'll return valid words. Maybe I should split this out into multiple functions or something, but this seems like it'll be okay for now. Does this solve the constraint you were thinking of, Matt? Where now we're looking at hints from a single word?
Sure, yeah. So we're basically applying each hint to the list as a filter.
Yes. So I'll just convert it to a list, but you probably don't need to. You can leave it as an iterable, and we're going to keep correct.
Though you didn't complete keep correct, right?
That's true. We need to fill this one out. I was just adding this one because I was going to make a bug.
Gotcha. Okay.
Super confused. But yeah, so now we have a word and we have clues about each of them. So we need to pairwise compare each letter and word with the hints. And if something is present, we need to keep the letter that is, or sorry, if something is correct, we need to keep the letter that is correct.
Mm-hmm.
So maybe we can do an all for this. And we need to do an index. So they should both be length 5. So let's do len word just for fun.
This is your fancy Adam Chapala Python coming out.
We'll see. I should use an enumerator or something then.
Yeah, somehow you have to zip at some point in this line.
I think zip would be the move, right? If you zip the word with the guess hints.
Yeah, that would definitely be the most pretentious bullshit way to solve this problem.
We can.
I'm okay with that.
All right.
I'm not above being pretentious.
Yeah,
We'll do
I
this.
kind of dig it.
We'll probably need to open one of these for my own sanity. So let's say our guess is this, and our hints is this. So let's just pick one of them to be correct.
I
And
always guess as diffke on Wordle. It's always my first guess.
that's my Wordle starting word. What's your guys?
Yeah.
Does that mean anything in Yiddish?
I'm just gonna.
Probably.
Who cares in all of these as long as they're not correct, which it still works. So 1, 2, 3, 4. We need one more. All right. So you guys are saying when you can do something. Let's just see what happens. Do I need to like unpack hints to make it work?
No, I think it should just work.
Okay, so we're not unpacking hints. And it is nested a little bit, which is annoying. I don't know a good way to unnest it without.
Oh, I see what you're saying. I mean, yeah, you could.
But that's okay. We can just deal with it this way. But we could also do. Yeah, I know you can do like another double zip to unnest this or something, but.
Well, you don't want to unnest, right? You need both pieces of information. You need to see if it's correct or not, and then check if the letters match.
That's true. I was hoping they would all be flat and we could be like compare the 0th and 1st index. But what do you have in mind? I guess is this
compare the.
Is this better than?
Sorry, go ahead.
Sorry, I asked you a question and interrupted you. But is this necessarily better than like? And
no, it's not necessarily better. Yeah, whatever makes more sense
okay.
to you. We should do that.
Unfortunately, I'm no Adam Chapala, and we'll do it this way. All right. So for in the length of word, we want word I equals yes hints. Wow, this is a really long and ugly line. Guess hints I only if guess hints of I says it's correct. Yikes. All right, let's just do this and hope Python still likes that. I don't think
if you make guess hints return Boolean, then you could just say if guess hints I.
If
like,
sorry.
If instead of returning correct or incorrect, guess hints each of those functions return 0 or 1 or true or false, then you could make the line shorter.
That's true. I am actually going to keep it because this is not going to be a Boolean thing. We can do absent and present, and there's
oh yeah, okay.
Oh wait, Max, I'm sorry. I guess you have to go now, right?
It's not super critical. Why don't we wrap up like in the next 5 minutes or so?
All right, so let's see how this does.
I just have to pick something up at a store that closes at 5. So like,
okay,
it's not the end of the world.
All right, so let's just see what happens and what silly bugs we have to fix at runtime. Len word.
So what's the I in Lenward? You probably want I in range Lenward?
That's a good point. Thank you.
Good one.
I like raid.
Although I kind of wonder why it compiled.
Because it was going to give us the letters and try to index into here, and Python's going to be like, your list can't take letters as index.
But why would it do for I in len word? Because len word's a number.
Yeah, it's dynamic. No, it's a good question.
Practically correct, and so you won't find out until runtime.
I see. Okay.
But the formal method in UMax is right. That's probably one you could statically.
Yeah.
We guess the first one here, and then something broke. Nice. And guess hints missing one positional argument. Where do we even call this? Line 37 in prune. Right over here.
It's filtered. So it's actually getting the tuple. Is that how it works? That would be really cool if that's how it works.
I think it is. Let's check. And if not, we'll finally use zip for you guys. And it's not. It got expected 2 arguments. It got 3. I thought it worked that way for map, honestly.
What are we calling? We're calling keep correct.
and it has two parameters, and we're passing two parameters like this. Maybe what I can do is, since we're defining a lambda function inside the function, we can just say ignore this. It already gives us hints, and that'll work.
I like that.
And let's see what happens. So this is probably going to work the first time because we got lucky and maybe break later, or that one. All right, I have 1 instead of I. I don't know what on earth that was. Oh, so hints is supposed to be a list, and I made the same mistake as before. Hints is a list of word hints. So
Are you missing a colon in hints with the -1 at the end of line 26?
I think it's more like this. And so, and it's more like anything is not correct, we return false, and if all of these make it through, then we return true. Okay. What I was doing before is I was assuming hints was one flat list. Instead, we need to check all of them.
You've got an extra S in guess hints.
No, I was wrong. We're looking at the last element of hints. It should have been fine before. So what am I missing here? We're saying we have our hints. This is a list of all the words we guessed, and we want to look at the last one here. And
right. Well, is it a list of the words we guessed, or is it the list of tuples?
It's the list of tuples. So there's one list of tuples per word. And what I had wrong is I had the wrong variable written here. So it was checking this. It was saying, sure, guess is not hitting this. So it ran this, but we didn't have our hints yet. So I think this will fix it actually. No, it did not. Let's print out what hints is.
So string index, yeah. Somehow hints is a list of strings instead of a list of tuples, and that's weird.
Interesting.
Empty strings.
Empty, and then it returns false. And then I think you're right. It is strings because I'm probably passing the wrong thing into all correct. I apologize.
That's how coding works.
All right, so fantastic. We're picking the first element in the list that matches with this one rule we have. That's great. So now maybe we can write a rule that excludes all the black ones.
You don't like just being really confident in your...
No, it's definitely a cigar, we promise. This one should be faster because we wrote all the infrastructure we need. So we want to filter not on just keep correct, but also on other things. So instead of just keep correct, we also want exclude incorrect or something. This one should be a bit easier. So, and this is actually where some of the complications come in.
Yeah, you want like a none.
Yeah, so,
right?
so we can write something that says we're going to get rid of all the black letters in here. And this is good based on our interpretation of what that means, but Wordle has something slightly weird, so it's not going to fully work. But let's do that. So we want to return true if all of those letters are excluded. So something like I not in word for I in what?
Okay.
Something like this. So the letter, we want to make sure that letter isn't in the word if this hint says what? Incorrect?
Absent?
Absent. All right. So now we're keeping the correct ones. There must be a faster way to do this, or a better way. Actually, what we'll do is we'll have a master rule or something. So exclude incorrect and keep correct both take a word as input.
So just compose them.
Yeah.
There's probably a fancy word for this. Like we're doing
Oh.
continuation passing style or something. I composed 2 functions the other day and Ken McMillan told me I was doing continuation passing style. I was like, I don't think so. I think I'm just composing functions.
All right, so we've got our few things and our filter. Let's see if we get something other than cigar this time. That would be nice.
Oh
Wow.
yeah.
Oh no, it looks like our first rule is wrong somehow.
It's okay. It's doing great.
I guess stool. I like that.
There you go, Max. So what do you guys think? Do you want to do discussion? Do you want to fix our first rule? What's the vibe right now?
For my own convenience, why don't I stop recording and then I'm going to drop off the call. And if you two want to have some discussion without me, you can go wild.
Okay, let
I'm
me
going to
put one comment in the discussion now before we record. So even if we fixed keep correct, and if we did exclude absent, and if we did the present ones, which is actually a slightly more complicated rule where you basically say this letter needs to be in the word, but we're excluding it from this specific spot. So it's like a combination of like excluding something from a spot. So very similar to keep correct, but then also checking that something is in a word. So the opposite, it's kind of like the opposite of both of these composed. Even if we do all of that, it will still break, because what Wordle does is, we had the example stool. Let's say that O is a valid letter in the word and we got it right. So like, I'll just do a quick example right here. So if this letter here is correct, it gets marked as green. Even though O is in the word, this doesn't get marked as yellow, this gets marked as black. Or if the valid O is over here, then this O is yellow and this O is black.
Mhm.
So basically Wordle does this thing that makes our lives pretty difficult, because in our guesses, we need to somehow keep track of the number of letters that are in a thing, because we don't want to say, oh, this O over here is black, we're going to exclude O from our next word, because we know there has to be at least one O in the word. But this is something we'd run into strategy. So I don't have a super clean solution for this. And there are a lot of ways we can write more complicated rules that could get around it. But what I was thinking of, if we had time, which we don't, that would have been really cool, is if instead of writing our rules, we actually do an intermediate modification of our hints and come up with other descriptions other than correct and present. And I don't know exactly what the answer is, and we don't have time to get into it today, but that is the issue with the rest of the solver. So we can do these strategies, it'll solve a bunch of words, and then it will break on a few special cases. And thank you for attending today. If there's interest, we can continue this in a future session.
Jacob, this is super cool. We should definitely do more of these. Great job live coding.
Thank you guys.
I'm going to end the recording now.